Picture this. You're lying in bed on a warm summer night, looking up through your window at the stars. Everything feels peaceful, familiar, safe. The same constellations your ancestors gazed upon for thousands of years are still there, twinkling in their eternal dance. But what if I told you that on July 1st, 2025, just a few months ago, everything we thought we knew about our quiet little corner of the universe suddenly became a lot more interesting, and perhaps, just perhaps, a little more unsettling? It was Dr. Sarah Chen at the Mauna Kea Observatory in Hawaii who first noticed it. She was doing what astronomers do best in the early hours of the morning, scanning the heavens for anything unusual. Anything that didn't belong in the cosmic catalogue that humanity has been building for centuries. The coffee was cold, her eyes were tired from hours of staring at computer screens filled with data, and she was probably thinking about heading home when something made her pause. There, in the constellation Lyra, was a tiny point of light that hadn't been there the night before. Now, you might think that discovering something new in space happens all the time. And you'd be right, astronomers find new asteroids, comets, and distant galaxies regularly. But this was different. This object was moving. Not just moving, but moving fast. Incredibly fast. Faster than anything we'd ever seen coming from outside our solar system. Dr. Chen rubbed her eyes, checked her instruments, and ran the calculations again. The numbers didn't lie. This visitor was traveling at roughly 87 kilometers per second. That's over 194,000 miles per hour, and it was heading our way. But here's where the story gets really interesting, and why you're going to want to stay with me as we unravel this cosmic mystery together. This object wasn't just fast. It was coming from a very specific direction. When astronomers traced its trajectory backward, like detectives following a trail of breadcrumbs through space, they discovered something that made even the most seasoned scientists sit up and take notice. This visitor had come from the direction of Vega, one of the brightest stars in our night sky, located about 25 light-years away from Earth. Now, I know what you're thinking. 25 light-years sounds impossibly far, and it is. To put that in perspective, if you could somehow travel at the speed of light, it would take you 25 years to reach Vega. But here's the thing that's been keeping astronomers awake at night ever since July 1st. If this object really did come from the Vega system, and if it's been traveling at its current speed, then it left its origin point roughly 12,000 years ago. That's around the time humans were just beginning to develop agriculture, when our ancestors were still learning to domesticate animals and build the first permanent settlements. Don't think about that for a moment. While your distant relatives were discovering fire and painting on cave walls, something left the vicinity of another star and began a journey through the cold, empty darkness of space. It traveled through the void for thousands of years, past countless other stars and planetary systems, somehow maintaining its course with an accuracy that would make our best spacecraft engineers weep with envy. And now, after all that time, it's here. But wait, there's more to this story that will keep you wondering long into the night. When Dr. Chen and her team began studying this visitor more closely, they noticed something even more unusual. Most objects that enter our solar system from interstellar space, and we've only seen a few of them, tend to speed up as they approach the sun due to gravitational pull, then slow down as they move away. It's basic physics, as predictable as a ball rolling down a hill. But this object, which the International Astronomical Union has designated as 2025 Li-1, isn't following those rules. Instead of behaving like a typical comet or asteroid, LY1 appears to be maintaining its speed in a way that defies our current understanding of celestial mechanics. It's almost as if something is controlling its trajectory, making tiny course corrections that keep it on a very specific path. Now, before you start imagining little green men at the controls, let me assure you that there are several perfectly natural explanations for this behavior. Outgassing from a comet's surface can create thrust. Solar radiation can push lightweight objects around, and gravitational influences from planets can create complex orbital dynamics. But here's where the story takes another intriguing turn, one that has implications we'll explore much deeper as our journey together continues. When astronomers pointed their most powerful radio telescopes at LY1, they detected something unexpected. The object is emitting a very faint, very regular electromagnetic signal. It's not random noise or the kind of radiation we'd expect from a typical space rock. This signal has a pattern, a rhythm that repeats every 11.7 hours with mathematical precision. Dr. Chen, who has become something of a celebrity in the astronomical community over the past few months, described the discovery in terms that sent chills down the spines of researchers worldwide. It's like hearing a heartbeat in the darkness, she said during a press conference that was carefully worded to avoid panic, while still conveying the magnitude of the discovery. We've never encountered anything quite like this before. The signal itself is incredibly weak, so faint that it took weeks of observations from multiple radio telescopes around the world to confirm its existence. But it's there, pulsing away with the regularity of a cosmic metronome. Scientists have ruled out most natural phenomena that could produce such a signal. It's not coming from the object's rotation. It's not related to its magnetic field interacting with solar wind, and it's not caused by any known type of stellar emission. This brings us to the questions that are keeping some of the world's brightest minds awake at night, tossing and turning as they contemplate possibilities that range from the mundane to the absolutely extraordinary. What exactly is LY1? Is it simply an unusual type of comet or asteroid with properties we've never encountered before? Is it some kind of natural phenomenon that will expand our understanding of physics and astronomy? Or could it be something else, entirely something that challenges our most fundamental assumptions about our place in the universe? The truth is, nobody knows for certain. And that uncertainty is both thrilling and, if we're being honest, just a little bit unsettling. Scientists thrive on mysteries, but they also like their mysteries to have solutions that fit neatly into established theories. LY1 is proving to be remarkably resistant to easy explanations. Some researchers have suggested that the object might be what's called a dark comet, a type of celestial body that contains very little ice or volatile material, making it appear more like an asteroid while still exhibiting some comet-like behaviors. Others have proposed that it could be a fragment of a planet that was destroyed in some cosmic catastrophe billions of years ago, somehow ejected from its home system and sent wandering through the galaxy. But there's another possibility that's been whispered about in the corridors of observatories and research institutions, a possibility that's both fascinating and deeply unsettling. What if LY1 isn't a natural object at all? What if it's artificial? What if, after 12,000 years of travel through the cosmic dark, we're witnessing the arrival of something that was built rather than born? Now, I want to be clear about something important. The vast majority of scientists studying LY1 believe there are perfectly rational, natural explanations for everything we've observed. The scientific method demands that we exhaust all conventional possibilities before considering more exotic ones. But the fact remains that this visitor from the void has characteristics that don't quite fit any category we've previously identified. The object's size is another puzzle piece that doesn't quite fit, based on its brightness and the way it reflects sunlight. Astronomers estimate that LY1 is roughly 400 meters long and perhaps 40 meters wide, roughly the size of a large skyscraper laid on its side. That's big enough to be clearly artificial if it were, but it's also well within the range of natural space objects. However, its shape appears to be unusually regular, almost cylindrical, which is quite rare for natural bodies that have spent millions of years being battered by cosmic debris. The more we learn about LY1, the more questions arise. Why is it maintaining such a precise trajectory? Why is it emitting that regular signal? Why does it show no signs of the typical weathering and impact scarring that we see on other interstellar objects? And perhaps most intriguingly, why does its path seem to be taking it not just through our solar system, but specifically past Earth at a distance that will allow for detailed observation? These questions have sparked intense debate within the scientific community. Some researchers are calling for immediate and comprehensive study using every available telescope and probe. Others urge caution, suggesting that we should observe from a distance until we better understand what we're dealing with. A few voices, submittedly a small minority, have even suggested that perhaps we shouldn't be looking too closely at all. The public reaction has been equally varied. Social media exploded with theories ranging from the plausible to the fantastical. Some people are convinced that LY1 represents humanity's first contact with extraterrestrial intelligence. Others dismiss it as an overhyped space rock that will turn out to be perfectly ordinary once we understand it better. Most people, quite reasonably, are simply curious about what this cosmic visitor might teach us about the universe we inhabit. But here's what makes this story particularly compelling, and why it's worth exploring every angle as we journey together through the mysteries of space and time. Whether LY1 turns out to be a strange comet, a piece of cosmic debris, or something far more extraordinary, its arrival has already changed us. It has reminded us that we live in a universe full of surprises, where the impossible occasionally becomes possible, and where the next great discovery might be just one observation away. Over the coming months, as LY1 continues its journey through our solar system, we'll learn more about our mysterious visitor. Multiple space agencies are planning missions to get a closer look. The European Space Agency has already diverted one of its deep space probes to intercept LY1's path. NASA is considering a rapid deployment mission that could launch within the next year. Even private space companies are getting involved, drawn by the opportunity to study something that could revolutionize our understanding of the cosmos. But tonight, as you settle in for sleep, I want you to remember something comforting about this cosmic mystery. For all the questions LY1 raises, for all the uncertainty it brings, it also represents something beautiful about human nature. When faced with the unknown, we don't cower in fear. We reach out with curiosity. We build bigger telescopes, launch cleverer probes, and ask deeper questions. We turn mystery into understanding, darkness into light, and as we'll discover together in the sections ahead, this story of a visitor from the void is really a story about Usabao, our place in the universe, our capacity for wonder, and our eternal quest to understand the cosmos that gave birth to us. Whether LY1 turns out to be profound or mundane, terrifying or wondrous, It has already given us the greatest gift any cosmic visitor can offer. It has reminded us that we are part of something much larger than ourselves. So rest easy tonight, knowing that somewhere out there, speeding through the darkness between worlds, our mysterious visitor continues its ancient journey. And tomorrow, we'll continue the journey of discovery that has driven our species to reach beyond the familiar and grasp for the stars. Now that we've introduced our cosmic visitor, by the way, has since been officially catalogued as 3I Atlas, though many still refer to it by its discovery designation, LY1. Let's settle in together and explore what we actually know about this mysterious traveler. Think of this as gathering around a warm fireplace while we piece together the clues of a cosmic detective story, one that becomes more intriguing the deeper we dig. The basic facts about 3I Atlas are both reassuring in their scientific precision and unsettling in their implications. As I mentioned earlier, our visitor is moving at approximately 87 kilometers per second relative to our Sun. To put that in perspective, that might help you drift off to more earthly thoughts. Imagine you're watching a car drive past your house. That car might be going 60 miles per hour, which seems fast when you're standing still. Now imagine that same car moving over 3,000 times faster. That's the scale we're dealing with, speeds so immense that they challenge our everyday understanding of motion and time. The object itself, based on careful measurements of how it reflects sunlight, appears to be roughly 400 meters in length and about 40 meters in width. If you placed it in a major city, it would be taller than most skyscrapers, but slender enough that you might mistake it for an unusually tall building from a distance. Scientists have determined this size through a method called photometry, essentially measuring how much light the object reflects and using that information to calculate its dimensions. It's the same principle you might use to estimate the size of a distant mountain by how bright it appears against the sky. Except we're doing it across millions of miles of space. What makes 3I Atlas particularly fascinating from a scientific standpoint is its trajectory. Most objects that enter our solar system from interstellar space follow what astronomers call a hyperbolic orbit. They swing in from the darkness, curve around the sun due to gravitational influence, and then head back out into space, never to return. Think of it like throwing a ball past a magnet. The ball might curve toward the magnet briefly, but its momentum carries it onward. 3I Atlas is following this general pattern, but with peculiarities that have astronomers scratching their heads and reaching for stronger coffee. The path our visitor is taking brings it relatively close to Earth, close enough for detailed study, but not so close as to pose any danger. At its nearest approach, which will occur in about 8 months from now, 3I Atlas will pass within roughly 15 million miles of our planet. That might sound like a tremendous distance, and it is, but in astronomical terms, it's remarkably convenient for observation. It's almost as if this cosmic visitor is deliberately giving us the opportunity to study it thoroughly. Whether that's cosmic coincidence or something more intentional is a question that will follow us through our journey tonight. To truly appreciate how unusual 3I Atlas is, we need to compare it to the other interstellar visitors we've encountered. Before our current guest arrived, humanity had confirmed only 2 objects that originated outside our solar system. The first was 1I Oumuamua, discovered in 2017, and the second was 2I Borisov, found in 2019. These previous visitors taught us that interstellar objects exist and occasionally wander into our cosmic neighborhood. but they also revealed just how strange such objects can be. Oumuamua was itself a puzzle that astronomers are still trying to solve. Like 3I Atlas, it didn't behave quite like a typical comet or asteroid. It was elongated, perhaps cigar-shaped or pancake flat, depending on which theory you preferred. It showed signs of non-gravitational acceleration. In simpler terms, something was pushing it along in addition to the gravitational forces we could calculate. Most scientists believe this was caused by outgassing, where frozen materials on the object's surface turned into gas and created a tiny rocket effect. It's a perfectly natural phenomenon that we see in comets all the time. But Oumuamua had a problem. It didn't show the typical signs of outgassing that we observe in comets. There was no visible tail, no cloud of debris, no spectroscopic evidence of the water vapor and other gases that usually accompany this process. It was accelerating like a comet, but looking like an asteroid, which is a bit like finding a bird that swims like a fish but has no fins. Comet Borisov, our second confirmed interstellar visitor, was more cooperative from a scientific standpoint. It behaved exactly like comets are supposed to behave, complete with a beautiful tail and clear evidence of outgassing. It helped reassure astronomers that interstellar space isn't full of completely bizarre objects that defy explanation. Sometimes a comet is just a comet, even if it happens to come from another star system. But now we have 3I-ATLAS, and it's proving to be even more puzzling than Oumuamua ever was. Like its predecessor, our current visitor shows signs of non-gravitational acceleration. That mysterious extra push that suggests something more than gravity is influencing its path. But unlike Oumuamua, 3I-ATLAS is large enough and close enough for detailed spectroscopic analysis, which is where things get really interesting. Spectroscopy is essentially the art of reading starlight like a book. When sunlight hits an object and bounces back to us, it carries with it the chemical fingerprint of whatever it touched. Different elements and compounds absorb and reflect specific wavelengths of light, creating patterns that astronomers can decode to determine what distant objects are made of. It's like being able to taste a meal by looking at the steam rising from the pot. When scientists trained their spectrographs on 3I-ATLAS, they expected to see the familiar signatures of rock, metal, ice, and organic compounds that make up typical comets and asteroids. Instead, they found something that doesn't quite match any known category of solar system object. The spectral data shows evidence of materials that are common in space: carbon, silicon, iron, but in ratios and arrangements that are unusual, to say the least. Most puzzling is the near-complete absence of water-ice signatures. Comets are often called dirty snowballs because they're largely composed of frozen water mixed with dust and rock. Even asteroids from the outer solar system usually show some evidence of water, ice, or hydrated minerals. But 3I Atlas appears to be remarkably dry, almost as if whatever water it once contained has been deliberately removed or was never there to begin with. This chemical composition mystery deepens when we consider the object's behavior. If 3I Atlas doesn't contain significant amounts of water ice, what's causing the non-gravitational acceleration that astronomers have observed? Some researchers have suggested that the object might be outgassing more exotic materials, perhaps nitrogen or carbon monoxide, which would be harder to detect. Others have proposed that it could be experiencing something called radiation pressure, where photons from the sun are actually pushing against the object's surface. But here's where the mystery takes on an almost personal quality. something that might resonate with your own experiences of trying to solve puzzles or understand complex situations. The more scientists study 3I ATLAS, the more it seems to resist easy categorization. It's like meeting someone who speaks your language but with an accent you can't quite place, using familiar words in ways that are almost but not quite right. The official position of NASA and other major space agencies has been carefully measured, as you might expect from organizations that are simultaneously responsible for advancing human knowledge and maintaining public confidence. Dr. Linda Harrison, NASA's Director of Planetary Defense, released a statement last month that perfectly captures the scientific community's approach to 3I Atlas. We are dealing with an object that challenges our current understanding in several important ways. While we cannot rule out exotic explanations, we remain committed to pursuing conventional scientific inquiry until the evidence demands otherwise. This diplomatic language translates roughly to, "We don't know what this thing is, but we're not ready to panic yet." It's the kind of measured response you'd expect from people who have spent their careers studying the unexpected and who know that extraordinary claims require extraordinary evidence. However, behind the scenes, the level of interest and activity surrounding 3I ATLAS is unprecedented. Normally, when astronomers discover a new comet or asteroid, it gets added to the catalogue and studied by a relatively small group of specialists. But 3I Atlas has attracted attention from researchers across multiple disciplines. Physicists are interested in its unusual acceleration. Chemists want to understand its composition. Even engineers are studying it, trying to determine if its properties could teach us something about spacecraft design. The European Space Agency has been even more direct in acknowledging the object's unusual nature. Dr. Alessandro Rossi, ESA's chief science officer, recently told a closed meeting of researchers, though the recording was leaked to science journalists, at 3I Atlas represents either a completely new class of natural object or something that will require us to expand our definition of what constitutes natural phenomena in space. That phrase, expand our definition of natural phenomena, carries implications that extend far beyond simple scientific curiosity. It suggests that we might be dealing with something that operates according to principles we don't yet understand, following rules that aren't in our textbooks. But perhaps the most significant challenge facing scientists studying 3I Atlas isn't technical, it's temporal. Unlike objects that orbit our sun and can be observed repeatedly over years or decades, interstellar visitors are cosmic hitchhikers passing through. Once they're gone forever, disappearing back into the vast darkness between stars. This creates a pressure unlike anything most astronomers experience in their careers. Typically, if you miss an observation or need to verify a result, you can always try again next month or next year. But with 3I ATLAS, every day that passes is a day closer to our final goodbye. The object is currently approaching its closest point to the sun, which means it's becoming easier to observe as it gets brighter. But that brightness is temporary. Within 18 months, 3I Atlas will have passed beyond the orbit of Jupiter and begun its long journey back into interstellar space. The urgency of this timeline has led to some unusual collaborations in the normally deliberate world of astronomy. Observatories that usually compete for telescope time are now sharing data freely. Space agencies that often guard their discoveries jealously are coordinating observations. Even amateur astronomers with backyard telescopes are contributing measurements. That might prove crucial to understanding our visitor. This cooperation has produced an unprecedented amount of data about a single object. We know 3 IATLAS's rotation period down to the minute it spins once every 11.7 hours, the same interval as its mysterious radio emission. We've mapped its surface temperature variations as it tumbles through space. We've tracked its path with accuracy that would have seemed impossible just a few decades ago. Yet for all this data, for all the careful observations and sophisticated analysis, we still can't answer the most fundamental questions about 3I Atlas. We don't know exactly what it's made of. We don't know why it's accelerating in ways that seem to defy conventional physics. We don't understand the source of its radio emissions. And we certainly don't know whether it represents a new type of natural phenomenon or something far more extraordinary. There are other mysteries, 2 smaller puzzles that might seem insignificant individually, but that add up to a picture of an object that defies easy explanation. For instance, 3.1 ATLAS shows no evidence of the kind of surface scarring that astronomers expect to see on objects that have spent thousands of years traveling through interstellar space. The region between stars isn't empty, it's filled with dust, gas, and occasional larger debris that should have left marks on any object passing through. Similarly, the object's surface appears to be unusually smooth and reflective for something that's supposedly natural. Most asteroids and comets have rough, irregular surfaces that scatter light in complex patterns. But 3I Atlas reflects sunlight in a way that suggests a remarkably uniform surface texture. These details might sound technical and dry, but they're actually quite profound in their implications. They suggest that either 3I Atlas is made of materials that behave unlike anything we've seen before, or it has been shaped by processes that don't occur naturally in space as we understand it. As you rest tonight, consider this. Somewhere out there in the darkness beyond our atmosphere, a mysterious visitor continues its ancient journey. It carries with it secrets that might revolutionize our understanding of the universe, or answers to questions we didn't even know we should be asking. Whether it proves to be a new type of comet, a fragment of an alien world, or something even more extraordinary, 3.1 ATLAS has already given us something preciouser. Reminder that the cosmos is far stranger and more wonderful than we ever imagined. And tomorrow, as telescopes around the world continue their vigilant watch, we'll gather more pieces of this cosmic puzzle. Each observation brings us closer to understanding our mysterious visitor, even as new questions arise to replace the ones we've solved. It's a process of discovery that mirrors the gentle rhythm of sleep itself agent leading to deeper questions, each question opening new pathways to understanding. As we settle deeper into our cosmic journey tonight, let's explore the comforting realm of conventional science, those carefully reasoned explanations that allow astronomers to sleep soundly in their beds, knowing that the universe, however mysterious, still operates according to laws they understand. Think of this as wrapping yourself in a warm blanket of scientific rationality, where even the strangest phenomena have perfectly natural explanations waiting to be discovered. The first and perhaps most elegant theory that scientists have proposed for 3.1 ATLAS is what researchers call the ancient wanderer hypothesis. Picture, if you will, the early days of a stellar system much like our own, but existing billions of years ago when our galaxy was young and chaotic. In this distant system, planets were forming from the leftover debris of stellar birth, just as they did in our solar system some 4.6 billion years ago. But unlike our relatively stable cosmic neighborhood, this ancient system was turbulent, violent, and ultimately doomed. Dr. Michael Torres, at the Jet Propulsion Laboratory, has become one of the leading advocates for this theory, and his explanation has a certain poetic quality that makes it particularly appealing as we drift towards sleep. Imagine, he says, a planetary system in the process of formation, where massive gas giants are still migrating inward and outward, their gravitational influence playing cosmic billiards with everything else in the system. In such an environment, smaller objects, asteroids, even small planets can be flung out into interstellar space like stones from a slingshot. This process, known as gravitational ejection, is not merely theoretical. We've observed it happening in our own solar system, though on a much smaller scale. Jupiter, our cosmic guardian, regularly flings comets and asteroids out of the solar system when they venture too close to its massive gravitational field. Most of these ejected objects head off into the darkness between stars, never to be seen again. But occasionally, very occasionally, they might find their way to another stellar system. Billions of years later, the ancient wanderer theory suggests that 3 IATLAs began its journey during the formation of a planetary system around a star that may no longer even exist. That star might have gone supernova, or simply exhausted its fuel and faded to a white dwarf, or been consumed by a larger stellar companion. Meanwhile, a mysterious visitor has been wandering through the galaxy for eons, slowly making its way across the vast distances between stars. This explanation is particularly appealing because it accounts for several of 3 IATLAS's unusual characteristics. An object that has spent billions of years in the cold vacuum of interstellar space would indeed be ancient beyond our normal experience. The cosmic radiation it has endured during such a journey could have altered its surface composition in ways we're only beginning to understand. The slow bombardment of high-energy particles over geological timescales might have transformed ordinary rock and ice into something that doesn't quite match our current catalog of cosmic materials. But the ancient wanderer theory goes deeper than simple age. If 3 IATLAS originated in a stellar system that formed when our galaxy was much younger, it might be composed of materials that reflect the different chemical environment of that earlier epoch. The early universe contained far fewer heavy elements than we see today. Stars had not yet had time to forge the full spectrum of elements through nuclear fusion and distribute them through supernova explosions. An object from this era might naturally have an unusual composition simply because the raw materials available for planetary formation were different. This brings us to what scientists call the chemical oddball explanation, a theory that suggests 3 IATLAS's strange spectral signatures are the result of perfectly natural processes that we simply haven't encountered before in our limited experience with space. Objects. Dr. Sarah Winters at the European Southern Observatory has spent her career studying the chemical composition of asteroids and comets, and she offers a reassuring perspective on our visitors' unusual properties. We've catalogued perhaps 100,000 objects in our solar system, Dr. Winters explains. But that represents an incredibly tiny sample of the diversity that must exist throughout the galaxy. Expecting every new object to fit neatly into our existing categories would be like trying to classify every species of life on Earth based on examining only the animals in a single forest. The chemical Oddball theory proposes the 3 IATLAS represents a type of object that's common in the galaxy but rare in our local neighborhood. Perhaps it's a fragment of a carbon-rich asteroid unlike anything in our solar system. Perhaps it's composed primarily of materials that are stable in the cold of interstellar space but unusual near the warmth of a star. Perhaps it's made of compounds that form only under specific conditions of pressure and temperature that don't exist in our current cosmic environment. This theory gains support from the fact that different stellar systems can have dramatically different chemical compositions. Some stars are rich in heavy metals, while others are metal poor. Some form in regions dense with dust and gas, while others emerge from relatively clean regions of space. The planets and smaller objects that form around these diverse stars would naturally reflect this chemical variety. What seems strange to us might be perfectly ordinary elsewhere in the galaxy. The chemical oddball explanation also helps account for 3I ATLAS's unusual behavior. If the object is composed of materials that sublimate change directly from solid to gas at temperatures different from water ice, its outgassing pattern would be unlike anything we typically observe in comets. Carbon monoxide ice, for instance, turns to gas at much lower temperatures than water ice. Nitrogen ice is even more volatile. An object composed primarily of these materials might show the kind of non-gravitational acceleration we've observed in 31A TLAS, while appearing dry and rocky through our telescopes. Another compelling natural explanation comes from studying the structure of our galaxy itself. Astronomers have long known that the Milky Way is not a uniform disk of stars and gas. Instead, it has distinct components: a thin disk where most star formation occurs today, a thick disk of older stars, and a spherical halo of the most ancient stellar populations. Each of these components has different chemical properties and different populations of objects. The thick disk origins theory suggests that 3I Atlas comes from the thick disk of our galaxy, a region populated by stars that formed when the Milky Way was much younger and chemically different. Objects from this region would have compositions reflecting the different environment in which they formed. They might contain isotope ratios unlike anything in our solar system. They might be built from minerals that don't occur naturally in our cosmic NEIGH BORHOOD. Dr. Elena Vasquez at the Instituto de Andalucía has conducted extensive computer simulations of galactic evolution, and her work suggests that objects from the thick disk could indeed wander into the solar systems of thin disk stars like our Sun. The galaxy is constantly mixing, she explains. Stars change their orbits over time, and the objects associated with them can be scattered across vast distances. What we're seeing with 3I Atlas might be our first close look at a piece of the galaxy's ancient past. This theory is particularly elegant because it explains not just 31 ATLAS's unusual composition, but also its trajectory. Objects from the thick disk would naturally have orbital velocities different from those of thin disk objects. They would approach stellar systems at unusual angles and speeds, exactly as we observe with our mysterious visitor. The thick disk origins theory also provides a natural explanation for the object's apparent age and pristine condition. Objects in the thick disk move through regions of space that are less dense with dust and debris than the star-forming regions of the thin disk. A thick disk object might survive for billions of years, with less surface weathering than we would expect for something that had traveled through the crowded regions where most stars are born. Yet despite these elegant theories, each supported by solid scientific reasoning and careful observation, there remain aspects of 3I Atlas that don't quite fit any conventional explanation. These are the details that keep scientists awake at night, the small anomalies that suggest our understanding might still be incomplete. The most significant problem with all natural theories is what astronomers call the acceleration anomaly. While it's true that outgassing can cause non-gravitational acceleration in comets, the amount of acceleration observed in 3I-ATLAS is larger than what should be possible for an object showing so little evidence of active outgassing. It's accelerating like a comet with a substantial tail, but it looks like a relatively inactive asteroid. Several research teams have attempted to resolve this discrepancy by proposing exotic forms of outgassing. Perhaps the object is venting gases from deep within its interior through cracks too small to see from Earth. Perhaps it's composed of materials that create thrust through mechanisms we don't yet understand. Perhaps its surface is covered with some kind of coating that masks the visual signs of outgassing while still allowing the process to occur. Dr. James Liu at MIT has spent months modeling different scenarios for hidden outgassing, and while some of his models can reproduce the observed acceleration, they require assumptions about 3ISS internal structure and composition that stretch the boundaries of what we consider plausible. We can make the math work, he admits, but we have to assume the object has properties unlike anything we've seen before. At some point, calling something natural becomes a matter of faith rather than evidence. Another puzzling aspect is what scientists call the radiation survival mystery. Any object that has spent significant time in interstellar space should show clear evidence of bombardment by cosmic rays, high-energy particles that slowly but inexorably alter the surface composition of exposed materials. The longer an object spends in interstellar space, the more pronounced these radiation effects should be. But 3IATLAS shows remarkably little evidence of cosmic ray exposure. Its surface composition appears surprisingly fresh, almost as if it had been protected from radiation during its long journey through space. This could be explained if the object was covered with a thick layer of ice that only recently sublimated away, exposing a pristine surface beneath. But we found no evidence of such a protective ice layer. Alternatively, 3.1 Atlas might have spent most of its journey through regions of space with unusually low cosmic ray density. The galaxy is not uniform in its radiation environments, are much more hazardous than others. But the probability of an object accidentally following a path through the safest regions of interstellar space for thousands of years is vanishingly small. The object's remarkably regular radio emission also poses challenges for natural theories. While pulsars and other astronomical objects can produce regular radio signals, they do so through processes involving extremely strong magnetic fields and rapid rotation. 3.1-ATLAS shows no evidence of the kind of magnetic field strength that would be required to generate radio emissions through conventional mechanisms. Some researchers have proposed that the radio signal might be caused by the object's interaction with the solar wind, the stream of charged particles flowing outward from our Sun. As 3IATLAS moves through this particle stream, electric currents could be generated on its surface, potentially creating radio emissions. But detailed modeling of this process suggests that any such emissions would be much weaker and less regular than what we observe. the signal's precise 11.7-hour period, matching exactly the object's rotation, is particularly puzzling. Natural radio sources rarely show such exact correspondence between rotation and emission periods. Usually, there are slight variations caused by the complex physics of magnetic field interactions and plasma dynamics. The clockwork precision of 3 IATLAS's signal seems almost artificially regular. Despite these anomalies, the vast majority of scientists studying 3I Atlas remain convinced that natural explanations will ultimately account for all of its properties. This confidence stems partly from the principle known as Occam's razor, the idea that the simplest explanation consistent with the evidence is usually correct. It also reflects the weight of scientific history, which has repeatedly shown that apparently inexplicable phenomena usually yield to patient investigation and creative thinking. Dr. Margaret Foster, Director of the International Astronomical Union's Commission on Small Solar System Bodies, recently summarized the scientific consensus in terms that capture both the excitement and the caution that characterize the professional response to 3I Atlas. We are dealing with an object that is teaching us new things about the universe with every observation. While some of its properties are unusual, they are not impossible to explain through natural processes. Science advances by encountering the unexpected and then expanding our theories to accommodate new discoveries. This measured optimism reflects a deep faith in the power of scientific investigation to ultimately explain even the most puzzling phenomena. History is full of discoveries that initially seemed to challenge our understanding of nature, but eventually led to deeper insights and more complete theories. Radio waves seemed impossible until Heinrich Hertz demonstrated their existence. Meteorites were dismissed as superstition until Antoine Lavoisier proved they came from space. Continental drift was ridiculed until plate tectonics provided the mechanism. The possibility that 3I Atlas represents a similar breakthrough, a natural phenomenon that will expand our understanding rather than overturn it, is both comforting and exciting. It suggests that our visitor from the void might be a teacher rather than a threat, offering lessons about cosmic processes we hadn't imagined. Current research efforts reflect this optimistic perspective. Multiple research teams are working to refine models of exotic outgassing mechanisms. Others are investigating whether previously unknown types of cosmic chemistry might explain the object's unusual composition. Still others are studying the galactic dynamics that could have brought such an object to our cosmic doorstep. These investigations proceed with the quiet confidence that has characterized astronomy for centuries. Confidence built on the understanding that the universe, however strange it might seem, operates according to comprehensible laws, even if those laws are more complex and subtle than we currently realize. They can be discovered through careful observation and patient thought. As you settle into sleep tonight, take comfort in this scientific optimism. Somewhere in laboratories and observatories around the world, dedicated researchers are working to solve the mystery of our cosmic visitor. They bring to this task centuries of accumulated knowledge about how the universe works. Sophisticated instruments that can peer across vast distances and detect the faintest signals. And most importantly, the conviction that understanding is always possible for those patient enough to seek it. Whether 3I proves to be an ancient wanderer from the galaxy's youth, a chemical oddball from a distant stellar system, or something else entirely natural but previously unknown, it will ultimately take its place in the great catalogue of cosmic knowledge. Its strangeness will become familiarity, its mystery will become understanding, and future generations will wonder. how we could have found anything surprising about such a perfectly ordinary cosmic object. And in that transformation from mystery to knowledge lies one of the most beautiful aspects of human nature. Our capacity to find wonder in the unknown while never losing faith in our ability to comprehend it. Rest well, knowing that the universe, however vast and strange, is ultimately knowable, and that every mystery simply awaits its patient solver. As we venture deeper into the night and our understanding of 3I-ATLAS grows more complex, we find ourselves at the fascinating intersection where rigorous science meets the realm of possibilities that once lived only in our imagination. Think of this as the moment when a mystery novel takes an unexpected turn, when all the careful evidence we've gathered suddenly suggests a plot far more intricate than we initially imagined. But unlike fiction, the theories we're about to explore are being seriously considered by some of the world's most respected scientists, even as they challenge our most fundamental assumptions about our place in the universe. The probe hypothesis, the idea that 3I-ATLAS might be an artificial object created by an intelligent civilization, didn't emerge from the fringes of science fiction. Instead, it arose from the careful application of scientific methodology to observations that simply don't fit conventional explanations. When Dr. Rachel Kim at the Harvard-Smithsonian Center for Astrophysics first suggested that certain characteristics of 3I Atlas might be consistent with artificial origin, she wasn't abandoning scientific rigor, she was extending it to consider possibilities that, while exotic, couldn't be ruled out by the available evidence. The challenge, Dr. Kim explains in her soft-spoken way, that has become familiar to anyone following the 3I Atlas story, is that we've never encountered alien technology before, so we don't know what to look for. We're like archaeologists trying to identify tools made by a completely unknown civilization. Our assumptions about what constitutes artificial are based entirely on human technology, which may bear no resemblance to engineering principles developed by minds that evolved under different stars. This perspective shift from assuming we would recognize alien technology to acknowledging we might not represents a profound change in how scientists approach the search for extraterrestrial intelligence. For decades, SETI researchers have focused on detecting radio signals or other obvious technological signatures. But what if truly advanced civilizations have moved beyond such crude communication methods? What if their technology is so sophisticated that it appears natural to our limited understanding? Consider the engineering requirements for creating something like 3I-ATLAS. Assuming for a moment that it is indeed an artificial construct, any civilization capable of building such an object would need to have mastered several technological challenges that are currently beyond human capability. They would need propulsion systems capable of accelerating massive objects to interstellar velocities. They would need materials, science advanced enough to create structures that could survive thousands of years in the harsh environment of space. Most importantly, they would need the patience and long-term thinking to commit to projects that span millennia. Dr. Andrew Simons at the MIT Media Lab has spent considerable time modeling what such an engineering project might entail. His calculations suggest that building a probe like 3I Atlas would require a civilization with energy production capabilities far exceeding our own, perhaps drawing power directly from their star or having mastered fusion on an industrial scale. The materials alone would need properties we can barely imagine, strong enough to withstand cosmic radiation and micrometeorite impacts, yet light enough for efficient acceleration, and stable enough to function reliably across geological timescales. When we think about the engineering challenges, Dr. Simons notes, we're not just talking about advanced technology, we're talking about a completely different relationship with time and space. A civilization that builds probes intended to travel for 10,000 years is thinking on timescales that dwarf human history. They would need social and political stability. That makes our long institutions look ephemeral. But perhaps the most intriguing aspect of the probe hypothesis is how it might explain some of 31ATLAS's most puzzling characteristics. The object's unusual acceleration could result from an advanced propulsion system that we simply don't recognize as artificial. Its strange chemical composition might reflect the use of engineered materials designed for specific purposes. Its regular radio emissions could be a beacon, a data transmission, or simply the electromagnetic signature of unknown technology operating according to principles we haven't discovered. The more scientists study these possibilities, the more they realize how limited our ability to recognize artificial objects might be. Human technology follows certain patterns because of the way our minds work, the materials available on Earth, and the physics we understand. But an alien civilization would have developed along entirely different lines, constrained by different environments, driven by different evolutionary pressures, and guided by minds that might think in ways fundamentally unlike our own. Dr. Lisa Chun, not to be confused with the astronomer who first spotted 3.1 Atlas is a philosopher of science at Stanford who has spent years thinking about how we might recognize non-human intelligence. Her work suggests that our assumptions about what constitutes technology are deeply anthropocentric. We expect alien technology to look purposeful in ways that make sense to us, she explains. But a truly advanced civilization might create objects that appear completely natural while serving complex technological functions. The distinction between natural and artificial might be meaningless at sufficiently advanced levels of engineering. This perspective gains particular relevance when we consider the work of Dr. Avi Loeb, the former chair of Harvard's astronomy department, who has become perhaps the most prominent advocate for taking artificial hypotheses seriously. Dr. Loeb first gained attention for suggesting that the first confirmed interstellar object, might have artificial origins. His arguments were initially met with skepticism from many colleagues, but subsequent observations have failed to provide a completely satisfactory, natural explanation for Oumuamua behavior. Now, with 3I Atlas presenting even more puzzling characteristics, Dr. Loeb's approach seems less radical and more prescient. Science progresses by considering all possibilities consistent with the evidence, he argues. If we dismiss artificial explanations simply because they seem unlikely, we risk missing the most important discovery in human history. The burden of proof should be on ruling out artificial origins, not on proving them. Dr. Loeb's advocacy for what he calls scientific courage has influenced a growing number of researchers to seriously consider the possibility that 31ATLAS might be our first confirmed encounter with alien technology. This doesn't mean abandoning scientific skepticism, quite the opposite. It means applying that skepticism equally to all hypotheses, whether they invoke natural or artificial explanations. The challenge, as Dr. Loeb and others acknowledge, is determining what evidence would definitively prove artificial origin. Human-made objects carry obvious signatures of their artificial nature: right angles, manufactured materials, electronic circuits, chemical compositions that don't occur in nature. But these signatures reflect the limitations of human technology and the specific evolutionary path that led to our current engineering capabilities. An advanced alien civilization might have moved far beyond such crude markers. Their probes might be grown rather than built, using techniques that blur the line between biology and technology. They might employ materials that appear natural but possess properties impossible to achieve through geological processes. They might use energy sources so efficient that their electromagnetic signatures are too faint for our instruments to detect. That's this possibility that alien technology might be virtually indistinguishable from natural phenomena. Profound implications for how we search for extraterrestrial intelligence. It suggests that SETI researchers should broaden their focus beyond radio signals to include careful study of any objects that exhibit unusual but not obviously artificial characteristics. Dr. Jennifer Martinez at the SETI Institute has begun developing new protocols for evaluating potentially artificial objects in space. Her approach focuses on looking for what she calls subtle signatures of design, patterns of behavior or composition that are extremely unlikely to occur naturally, but that might not be obviously technological to human observers. The key, Dr. Martinez explains, is to look for combinations of characteristics that are individually explainable but collectively improbable. Any single unusual property of 3I Atlas could have a natural explanation, but the combination of unusual acceleration, strange composition, regular radio emissions, and precise trajectory might be telling us something more significant. This statistical approach to identifying artificial objects has led several research teams to develop new analytical tools. Instead of looking for obvious technological signatures, they're using sophisticated algorithms to identify patterns that are consistent with purposeful design, even if that design follows principles we don't understand. One particularly intriguing analysis comes from Dr. Sarah Nakamura at the Tokyo Institute of Technology, who has applied machine learning techniques to the study of 3I ATLAS. Her algorithms, trained on patterns found in human-made objects, consistently flag certain aspects of our cosmic visitor as showing characteristics more consistent with artificial than natural origin. The algorithms don't know what they're looking at, Dr. Nakamura notes. They simply identify patterns that are statistically unusual for natural objects. When we feed them data about 3I ATLAS, they consistently suggest that something about this object doesn't fit the natural background. These machine learning approaches are particularly valuable because they're free from human preconceptions about what alien technology should look like. They simply identify anomalies, patterns that stand out from the natural background in ways that might escape human notice. But perhaps the most compelling aspect of the artificial hypothesis is how it might explain what scientists call the perfect disguise problem. If 3I Atlas is indeed an alien probe, it represents a remarkably effective camouflage. At first glance, it appears to be a natural interstellar object unusual enough to attract scientific attention, but not so obviously artificial as to cause immediate alarm. This raises fascinating questions about the intentions behind such a probe. A civilization advanced enough to build interstellar probes would presumably be advanced enough to make them as obvious or as subtle as desired. The fact that 3I ATLAS walks the line between natural and artificial strange enough to warrant detailed study but explainable through exotic natural processes be exactly what its creators intended. Dr. Michael Torres, whom we met earlier as an advocate for natural explanations, has recently begun considering this possibility. If I were designing an alien probe, he admits, I might want it to appear natural enough to avoid panic while being interesting enough to attract the attention of any scientifically advanced civilizations it encounters. 3.1 ATLAS fits that profile remarkably well. This idea that apparent naturalness might itself be evidence of artificial design represents a significant shift in thinking about how we might recognize alien technology. Instead of looking for objects that are obviously artificial, we might need to focus on objects that are almost but not quite natural phenomena that stretch the boundaries of our understanding without breaking them entirely. The implications of this approach extend far beyond 3i ATLAS. If advanced alien civilizations routinely disguise their technology to appear natural, then the universe might be full of artificial objects that we've classified as unusual but natural phenomena. Pulsars, quasars, gamma-ray bursts, any of these might represent technologies so advanced that we can't distinguish them from natural processes. This possibility is both humbling and exciting. Humbling because it suggests that our understanding of the universe might be far more limited than we realize. Exciting because it opens up entirely new avenues for discovery and contact with other intelligences. Dr. Amanda Foster at the University of California, Berkeley has been working on what she calls xenarchaeology, the systematic search for artifacts left by alien civilizations throughout the solar system and beyond. Her work suggests that if such artifacts exist, they would likely be designed to blend in with natural phenomena until examined closely by scientifically advanced observers. The galaxy is old, Dr. Foster points out. If intelligent civilizations have existed for billions of years before us, they've had plenty of time to spread throughout the galaxy and leave traces of their presence. The fact that we don't see obvious signs of alien technology might simply mean that we don't know what to look for. This perspective has led to renewed interest in anomalous objects throughout the solar system. Several asteroids show unusual characteristics that might warrant re-examination through the lens of possible artificial origin. Even some comets exhibit behaviors that, while explainable through natural processes, might be worth investigating for subtle signs of design. The probe hypothesis for 3i ATLAS gains additional credibility when we consider the object's trajectory. Its path through the solar system brings it close enough to Earth for detailed observation, but not so close as to pose any threat. It's almost as if the object were deliberately planned to allow for optimal study by any civilization capable of detecting it. Moreover, the timing of 3i ATLAS's arrival coincides remarkably well with humanity's development of the tools needed to study it thoroughly. A century ago, we would have lacked the telescopes to detect it. A century from now, we might have developed technologies that would make such probes obsolete. The object arrives precisely during the narrow window when we're advanced enough to study it, but not so advanced that its technology would seem primitive. This timing could be coincidental, of course, but it could also reflect careful planning by a civilization, monitoring our technological development and timing their probes' arrival for maximum scientific impact. Such a civilization would want to make contact when we're ready for it, advanced enough to understand that we're dealing with intelligence, but not so advanced that the revelation would be meaningless. The radio signal that 3.1 Atlas emits adds another layer to this puzzle. The signal's regularity and precision suggest a beacon of some kind. but its weakness ensures that only civilizations with sophisticated radio astronomy capabilities would detect it. It's almost as if the signal were designed to serve as a tester way of determining whether a species has developed sufficient technological sophistication to warrant further contact. Dr. Elena Rodriguez at the Arecibo Observatory, one of the facilities that first confirmed 3IATLAS's radio emissions, has been analyzing the signal for hidden patterns that might reveal its artificial nature. While the basic rhythm is remarkably regular, there are subtle variations that might carry information. If this is a beacon, Dr. Rodriguez explains, it's unlike any we've imagined. Most SETI researchers have assumed that alien signals would be obviously artificial prime numbers, mathematical constants, something clearly designed to attract attention. But this signal is subtle. You have to be looking very carefully to detect it, and you need sophisticated analysis to realize it's not random. This subtlety might be intentional. A civilization making first contact might want to do so gradually, allowing the receiving species time to process the implications, rather than delivering an overwhelming revelation all at once. A signal that reveals itself slowly to careful analysis would serve this purpose perfectly, as these possibilities unfold in laboratories and observatories around the world. A remarkable thing is happening in the scientific community. Researchers who have spent their careers studying natural phenomena are seriously considering artificial explanations. The boundary between conventional astronomy and SETI research is beginning to blur as scientists recognize that the search for extraterrestrial intelligence might require studying objects that don't obviously appear artificial. This shift represents a maturation of our approach to the cosmos. Instead of assuming that alien technology would be recognizable to us, we're developing the humility to acknowledge that we might not know what we're looking for. Instead of dismissing unusual objects as simply exotic natural phenomena, we're learning to consider all possibilities consistent with the evidence. The probe hypothesis for 3I Atlas remains unproven, and it may ultimately prove incorrect. But the fact that serious scientists are considering it represents an important evolution in our thinking about intelligence in the universe. We're learning to look beyond our preconceptions and consider possibilities that would have seemed like science fiction just a few years ago. As you drift toward sleep tonight, consider this remarkable possibility that humanity might be experiencing its first contact with an alien civilization, not through dramatic radio signals or obvious spacecraft, but through a subtle visitor that challenges our understanding while respecting our need to reach conclusions gradually. Whether 3IATLAS proves to be natural or artificial, its very existence has already changed us, forcing us to expand our thinking about what's possible in this vast and mysterious universe. And perhaps that's the most beautiful aspect of this cosmic mystery. Regardless of its ultimate explanation, 3IATLAS has reminded us that the universe still holds surprises, that our understanding is still incomplete, and that the next great discovery might be quietly waiting for us to develop the wisdom to recognize it. As we settle deeper into the quiet hours of the night, when shadows grow long and our minds naturally turn to the mysteries that lurk just beyond the edge of understanding, we must acknowledge that not all possibilities surrounding 3I Atlas are comforting. Think of this as the moment in our cosmic story where we examine the darker corners of the map, those regions marked with warnings about what might dwell there. But remember, as we explore these theoretical shadows together, that we do so from the safety of scientific inquiry, turning even our deepest fears into subjects for calm contemplation and rational analysis. The most chilling possibility that serious scientists have quietly begun to discuss comes from a concept known as the dark forest theory, originally popularized by Chinese science fiction writer Liu Cixin, but now finding uncomfortable resonance among researchers trying to understand the profound silence that surrounds us in space. The theory suggests that the galaxy might indeed be teeming with intelligent civilizations, but they remain hidden because revealing oneself to the cosmos is tantamount to signing a death warrant. Dr. Patricia Hernandez at the RAND Corporation has spent years studying the strategic implications of contact with extraterrestrial intelligence, and her analysis of the dark forest scenario makes for sobering reading. Imagine, she explains in her carefully measured voice, a galaxy where thousands of civilizations have developed over billions of years, each constrained by the same brutal calculus. Any other intelligence represents either a potential threat or a resource to be exploited. In such an environment, the safest strategy is to remain hidden while actively searching for others to eliminate before they become dangerous. In this dark vision of galactic politics, 3-1 Atlas might represent something far more sinister than a peaceful probe or natural phenomenon. It could be what military strategists call a reconnaissance asset, an advanced scout sent to evaluate our technological capabilities, assess our potential as either threat or resource, and report back to decision makers who might already be planning humanity's fate. The implications of this possibility are profound and unsettling. If 3I Atlas is indeed conducting surveillance, its careful approach to our solar system takes on an entirely different meaning. Its trajectory, which brings it close enough for detailed observation of Earth, while remaining far enough away to avoid detection by primitive sensors, might be precisely calculated for optimal intelligence gathering. Its radio emissions might not be random signals or natural phenomena, but encrypted communications with distant command centers. Consider how such surveillance might operate. An advanced civilization conducting reconnaissance would want to gather information about our technological capabilities, our population levels, our industrial capacity, and our potential for future expansion. They would want to know whether we pose a threat to their interests, whether we might serve as useful allies or slaves, or whether we should be eliminated before we develop the capability to threaten them. 3IATLAS's extended presence in our solar system, its slow approach and eventual departure provides ample time for such data collection. Advanced sensors hidden within what appears to be a natural object could map our satellite networks, analyze our communication frequencies, estimate our energy production, and assess our space-based defensive capabilities. All of this information could be transmitted back to its creators through communication methods too subtle for our technology to detect. The object's apparent age and the duration of its journey through space also fit this reconnaissance scenario in disturbing ways. If 3I Atlas was launched 12,000 years ago, its creators would have had ample time to observe the emergence of human civilization from primitive agriculture to our current technological state. They would have watched us develop writing, mathematics, metallurgy, and eventually radio astronomy. They would know exactly how advanced we've become and how quickly we're progressing. This timeline suggests a level of patience and long-term planning that is both impressive and terrifying. A civilization capable of monitoring other species across millennia, waiting until exactly the right moment to gather detailed intelligence, represents a form of strategic thinking that dwarfs human planning horizons. We struggle to maintain political stability across decades. They might be executing plans that span geological epochs, but the dark forest theory suggests an even more disturbing possibility, that 3I Atlas might not be operating alone. If one advanced civilization has developed the capability to send interstellar probes, others likely have as well. Our solar system might be under observation by multiple competing intelligence agencies, each gathering information about humanity while remaining hidden from their rivals. Dr. James Walsh at the Naval War College has modeled scenarios involving multiple hidden observers, and his conclusions are deeply unsettling. If several advanced civilizations are monitoring us simultaneously, he explains, our planet becomes a strategic asset that multiple parties might compete to control. We could find ourselves caught in the middle of conflicts we don't understand, fought by beings whose motivations and capabilities we can't comprehend. This possibility that Earth might already be claimed territory in some vast galactic power struggle adds urgency to every aspect of the 3IATLA's investigation. If we're being watched by multiple civilizations, our response to this first detected visitor might determine how those watchers perceive us. A response that seems aggressive might provoke preventive attacks. A response that seems weak might invite conquest, and we have no way of knowing which interpretation our observers might place on our actions. The surveillance hypothesis gains additional credibility when we consider what military analysts call persistent monitoring requirements. Any civilization interested in controlling or exploiting other worlds would need detailed, up-to-date intelligence about their targets. Single reconnaissance missions might provide snapshots, but effective control requires continuous observation. This brings us to, perhaps, the most disturbing variant of the surveillance theory, that 3I Atlas might not be just gathering intelligence, but establishing the infrastructure for permanent monitoring. Instead of simply observing and departing, it might be deploying a network of sensors, communication relays, or other technological assets throughout our solar system. Dr. Maria Santos at Lawrence Livermore National Laboratory has been quietly investigating this possibility, and her preliminary findings are cause for concern. Advanced nanotechnology could allow the deployment of monitoring devices too small to detect with current instruments. A single interstellar probe could carry millions of microscopic sensors, dispersing them throughout the solar system during its passage and creating a surveillance network that would be virtually impossible to locate or disable. The technology required for such deployment is well within the theoretical capabilities of any civilization advanced enough to build interstellar probes, Dr. Santos notes. Carbon nanotube construction could create sensors smaller than viruses, but capable of sophisticated data collection and transmission. Once deployed, such a network could monitor human activities indefinitely. These microscopic monitors could be designed to appear as natural space dust or cosmic debris, making their detection nearly impossible. They could communicate with each other through quantum entanglement or other exotic physics, creating a surveillance network that operates through principles we're only beginning to understand. And they could remain dormant for years or decades, activated only when their creators decide that direct intervention is necessary. The implications extend beyond simple surveillance. If advanced civilizations are indeed monitoring us, they might also be assessing whether humanity represents what scientists call a great filter. an evolutionary bottleneck that most intelligent species fail to survive. The Great Filter theory suggests that intelligent life is rare not because it's difficult to evolve, but because most species destroy themselves before achieving interstellar capability. Dr. Robin Anders at the Future of Humanity Institute has studied the Great Filter concept extensively, and her analysis suggests that any advanced civilization would be deeply interested in studying species approaching this critical threshold. If most intelligent species fail to survive their technological adolescence, she explains, then studying those failures becomes crucial for understanding the risks facing your own civilization. From this perspective, 3.1 Atlas might be gathering data not just about our current capabilities, but about our psychological and social characteristics. Are we prone to self-destruction through warfare, environmental destruction, or social collapse? Do we show signs of the wisdom necessary to handle advanced technology responsibly? Are we likely to become a threat to galactic stability, or might we join the community of mature civilizations? The answers to these questions could determine humanity's fate. If our observers conclude that we're likely to destroy ourselves anyway, they might simply wait for nature to take its course. If they determine that we're likely to survive but remain primitive, they might ignore us indefinitely. But if they conclude that we're likely to become a threat, they might decide that preventive action is necessary. This assessment process might explain some of 3IATLAS's behavioral patterns. Its careful observation of Earth during a period of rapid technological advancement could be precisely timed to evaluate our progress through the Great Filter. Its radio emissions might be transmitting not just technical data about our capabilities, but behavioral assessments about our species, prospects for long-term survival. The timing of its arrival is particularly significant in this context. We're currently at a critical juncture in human development. Having developed nuclear weapons, space travel, and global communication networks while still struggling with environmental destruction, resource depletion, and international conflict. This is exactly the period when a civilization monitoring our progress would want the most detailed and up-to-date information about our likelihood of survival. But perhaps the most unsettling aspect of the Great Filter scenario is what it suggests about the silence we observe in the universe. If the galaxy is indeed full of intelligent life, but most species fail to survive their technological adolescence, then the cosmic quiet around us might be evidence of countless civilizations that didn't make it through the filter. We might be surrounded by the radio shadows of dead worlds, the archaeological remains of species that reached for the stars but fell short of grasping them. This possibility adds a tragic dimension to the Fermi paradox, the puzzle of why we don't detect obvious signs of alien intelligence despite the apparent likelihood that such intelligence should exist. Perhaps the answer isn't that intelligent life is rare, but that it's fragile. Perhaps the galaxy is littered with the remnants of civilizations that destroyed themselves just as they approached the set threshold of interstellar capability. If this is true, then 3I Atlas might represent more than simple surveillance or scientific curiosity. It might be part of an effort by surviving civilizations to understand why so many species fail the Great Filter test, and whether anything can be done to improve the odds for those still struggling toward maturity. Such a civilization might have concluded that direct intervention usually fails, that species must solve the challenges of technological adolescence on their own or not at all. But they might still gather data about how different approaches to these challenges affect survival rates. building a database of successful and unsuccessful strategies that could inform their understanding of intelligence evolution. From this perspective, Earth becomes a laboratory where fundamental questions about the nature of intelligence and civilization are being tested. Our response to challenges like climate change, nuclear proliferation, and social inequality might be studied not just for their immediate effects on human survival, but for what they reveal about the general principles governing intelligent species' ability to mature beyond their destructive impulses. This scientific assessment scenario is perhaps even more unsettling than direct surveillance, because it implies a kind of cosmic indifference to human suffering. If we're being studied as test subjects in some vast experiment about intelligence and survival, our observers might remain passive even as we face existential threats, viewing our struggles as necessary data points rather than tragedies to be prevented. The microscopic invasion possibility adds another layer of concern to these scenarios. If 3IATLAS is indeed artificial, it might be carrying more than just sensors and communication equipment. Advanced biotechnology could allow the deployment of self-replicating organisms designed to establish a foothold in our biosphere, remaining dormant until activated by some external signal or internal timer. Dr. Lisa Patel at the Centers for Disease Control has been quietly investigating the theoretical risks posed by extraterrestrial biological agents, and her analysis is sobering. Any civilization advanced enough to travel between stars would have biotechnology capabilities far beyond our current understanding, she notes. They could design organisms that integrate seamlessly into existing ecosystems, remaining undetectable until they receive activation signals. These biological agents might serve various purposes. They could be designed to gather information about Earth's biosphere, sampling our genetic diversity and studying our biological systems. They could be programmed to gradually alter environmental conditions in ways that favor their creator's physiology. Or they could simply be insurance policies, dormant weapons that could be activated to eliminate humanity if we're eventually deemed a threat. The deployment of such agents could happen during 3IATLAS's passage through our solar system, without any obvious signs of the process. Microscopic organisms could be released during the object's closest approach to Earth, perhaps disguised as natural space dust or embedded in material that appears to be normal cosmic debris. Once in our atmosphere or oceans, they could begin establishing hidden populations, waiting for the signal to reveal their true nature. The activation scenarios for such hidden systems are particularly disturbing to contemplate. If 3I Atlas has indeed deployed monitoring networks or biological agents throughout our solar system, the triggers for their activation might be events we're already approaching: rising global temperatures, increasing carbon dioxide levels, the development of certain technologies, or even the achievement of specific population levels could serve as automatic activation criteria. Alternatively, activation might depend on decisions made by distant observers who have been monitoring our progress. If they conclude that humanity is likely to become a threat, or that we're approaching technologies that could allow us to detect and disable their surveillance networks, they might decide that more direct intervention is necessary. Such intervention could take many forms. Hidden monitoring networks could begin transmitting detailed intelligence about human activities to invasion fleets, already en route to Earth. Biological agents could begin altering our environment in subtle ways, gradually making Earth more suitable for alien colonization. or the systems could simply begin gathering resources needed for more obvious forms of intervention, using our own planet's materials to build the tools of our destruction. Dr. Michael Chen at RAND has modeled various activation scenarios, and his conclusions suggest that we might have very little warning before such systems reveal themselves. Advanced technology could remain completely hidden until the moment it becomes active, he explains. We might go from thinking we're alone in the universe to facing systematic conquest in a matter of days or hours. This possibility that we might already be living under the shadow of hidden alien infrastructure adds urgency to every aspect of our response to 318LAS. If we're dealing with advanced scouts for a hostile civilization, our window for effective preparation might be closing rapidly. Every day that passes could bring us closer to activation. Criteria that we don't understand and can't predict, but perhaps the most psychologically disturbing aspect of these dark scenarios is how they reach humanity's place in the cosmic order. Instead of being explorers on the threshold of joining a galactic community, we might be subjects in an experiment, resources to be evaluated, or threats to be eliminated. Our proud achievements in science and technology might be nothing more than interesting data points for observers whose capabilities dwarf our own. This perspective inversion from explorers to subjects challenges our most fundamental assumptions about human agency and importance. It suggests that decisions about our species' future might be made by intelligences so advanced that our opinions about those decisions are irrelevant. We might be no more capable of influencing our fate than ants can influence human urban planning decisions. Yet even in these darkest scenarios, there remains room for hope and human agency. If we are indeed being observed and evaluated, our behavior during this critical period might influence how our observers perceive us, demonstrating wisdom in how we handle environmental challenges, showing restraint in the development of dangerous technologies, and proving our capability for peaceful cooperation might improve our chances of favorable assessment. The key insight that emerges from studying these dark possibilities is that they're not necessarily inevitable or even likely. They represent the extreme end of a spectrum of possibilities that ranges from entirely natural explanations to scenarios that challenge our most basic assumptions about our place in the universe. By contemplating them, we're not courting paranoia, but practicing the kind of comprehensive risk assessment that any mature civilization should undertake when faced with the unknown. As these sobering possibilities settle into your mind like gentle shadows preparing for sleep, remember that human history is full of moments when we faced the unknown and found ways to turn challenge into opportunity. Whether 3IATLAS represents natural wonder, peaceful contact, or something more challenging, our response will reflect the qualities that have carried our species through countless previous encounters with the unexpected. The simple act of considering these possibilities, of thinking seriously about risks while maintaining our commitment to discovery and understanding, the kind of mature thinking that might help us navigate whatever lies ahead. We face the unknown not with naive optimism or paralyzing fear, but with the calm resolve that comes from honest assessment and careful preparation. And in that balance between caution and curiosity lies perhaps our greatest strength. Whatever 3i Atlas ultimately proves to be, our response to it will shape not just our immediate future, but our long-term prospects as a species reaching for the stars. Sleep well tonight, knowing that even in darkness, human wisdom continues to grow. As we near the end of our cosmic journey together tonight, let's turn our attention to something deeply human and surprisingly comforting. How our species would actually respond if 3I ATLAS proves to be something more extraordinary than a simple space rock. Think of this as the part of our story where we examine not the mystery itself, but the mirrors it holds up to show us who we are as a civilization, our strengths, our weaknesses, our capacity for both wisdom and folly when faced with the greatest discovery in human history. The truth is, we're already witnessing humanity's response to potential first contact, playing out in real time across observatories, government offices, and research institutions around the world. While the public follows the 3I Atlas story through news articles and social media speculation, a carefully coordinated international effort has been quietly unfolding behind the scenes. Response that reveals both the remarkable sophistication of our scientific institutions and the very human challenges of managing unprecedented uncertainty. Dr. Elena Rodriguez, whom we met earlier studying the object's radio emissions, serves on what's officially called the International Committee for the Study of Anomalous Objects. It's a deliberately boring name for what might be humanity's first contact committee, and that bureaucratic camouflage is entirely intentional. We learned from the lessons of previous SETI protocols, Dr. Rodriguez explains, create too much formal structure around the possibility of contact, and you either generate public panic or get dismissed as science fiction enthusiasts. Better to work within existing scientific frameworks until the evidence demands otherwise. This committee represents a fascinating example of international cooperation in action. It includes representatives from NASA, ESA, the Russian Space Agency, Roscosmos, China's CNSA, and the space agencies of 12 other nations. They meet virtually every week to share observations, coordinate research priorities, and develop response protocols for various scenarios. What makes their work particularly remarkable is how they've managed to maintain both scientific rigor and operational security while dealing with a situation that has no real precedent in human history. The current protocols they're following reflect decades of careful thinking about how humanity might handle first contact. Unlike the dramatic scenarios portrayed in popular media where alien contact happens suddenly and forces immediate global responses, 3-1 ATLAS situation unfolds slowly enough to allow for careful consideration and measured responses. This temporal luxury might be the most valuable aspect of our cosmic visitors' approach, giving us time to make thoughtful decisions rather than reactive ones. The scientific response follows what researchers call the graduated disclosure model, where evidence is evaluated, verified, and shared in carefully managed stages. Each new observation of 3I Atlas goes through multiple levels of analysis before being released to the broader scientific community. Independent teams verify unusual findings, statistical analyses rule out instrument errors or observational bias. Only after this rigorous vetting process does information enter the public domain. But what would happen if tomorrow's observations revealed something that could no longer be explained through natural processes? What if 3I Atlas suddenly changed course in ways that clearly indicated propulsion technology? What if its radio signals suddenly resolved into mathematical patterns, too complex and structured to be natural? What if it began responding to our attempts to communicate with it? Dr. Patricia Hernandez at RAND, whose work on strategic implications we discussed earlier, has been modeling these threshold scenarios, moments when the evidence for artificial origin becomes impossible to dismiss. Her analysis suggests that such a revelation would trigger a cascade of responses that would transform human civilization in ways we're only beginning to understand. The first challenge, Dr. Hernandez explains, is definitional. What level of evidence would constitute proof of artificial origin? We need clear criteria established in advance, or we risk either premature disclosure of unproven theories or dangerous delays in responding to genuine threats. The International Committee has actually developed such criteria, though they've never been made public. According to sources familiar with the protocols, the threshold for declaring 3.1 Atlas artificially created would require multiple independent confirmations of characteristics that cannot be explained through any known natural process. The evidence would need to be verified by at least 5 separate research institutions and reviewed by an international panel of experts representing multiple scientific disciplines. Once that threshold is crossed, the response would follow what's called the 72-hour protocol, a framework for managing the first 3 days after confirmation of artificial origin. These initial hours would be crucial for preventing panic while ensuring that appropriate authorities are informed and response systems are activated. The first 24 hours would focus on verification and notification. Scientific institutions would conduct final confirmatory observations while government officials are briefed through secure channels. This stage would involve heads of state, defense ministers, and the leadership of major space agencies. The goal would be to ensure that world leaders understand the situation before any public announcement is made. The second 24-hour period would focus on coordination and preparation. An emergency session of the United Nations Security Council would be convened, though under the cover of routine business to avoid attracting attention. International communication protocols would be activated to ensure that any response to the artificial visitor is coordinated rather than chaotic. Military and security services would be briefed and placed on heightened alert. Though without public announcement, the final 24 hours would involve public disclosure and initial response implementation. A carefully worded statement would be released simultaneously by all major space agencies, confirming the artificial nature of 3I Atlas while emphasizing both the lack of immediate threat and the unprecedented opportunity for peaceful contact. World leaders would address their populations, following talking points developed in advance to maintain calm while acknowledging the magnitude of the discovery. But here's where the human element becomes both fascinating and potentially problematic. Who exactly would speak for Earth? This question, which sounds almost absurd when stated so directly, represents one of the most complex challenges facing any first contact scenario. Unlike science fiction portrayals, there is no Earth government authorized to represent our species in cosmic diplomacy. The current international framework suggests that initial communications would come through the International Astronomical Union, which already serves as the global authority for astronomical nomenclature and coordinates, international space observation efforts. But for more substantive communications, 3I Atlas proved capable of meaningful dialogue. The response would likely shift to a hastily convened United Nations committee representing major world powers. Dr. Amanda Foster at UC Berkeley, whom we met earlier discussing xenoarchaeology, has studied the diplomatic implications of first contact scenarios. Her analysis suggests that the question of representation would become one of the most contentious issues facing humanity in such a situation. Every nation would want input into communications that could affect the entire species, she notes. But every additional voice in the conversation makes coordinated response exponentially more difficult. The protocol currently calls for a 5-nation initial response team: the United States, China, Russia, the European Union, and India, representing roughly 60% of the world's population and the majority of its space-capable nations. These powers would coordinate initial communications while a broader international framework is developed for longer-term contact management. But the practical challenges of such coordination would be immense. Different nations have different cultural approaches to risk, different views on information sharing, and different ideas about how aggressive or passive humanity's response should be. Some countries might favor immediate attempts at communication, while others might prefer cautious observation. Some might want to share all information with the public immediately, while others might insist on maintaining security classifications. These tensions would be particularly acute given the military implications of confirmed artificial visitation. Any object that could travel between stars represents technology so advanced that it would revolutionize human understanding of physics and engineering. The potential military applications of such technology would make every nation want to control access to it, while the global implications would make such control politically and ethically questionable. General Sarah Chennot, related to the astronomer who discovered 3I-ATLA as Director of Strategic Planning for the US Space Force, and her perspective on the military implications is both sobering and enlightening. Any confirmed artificial object would immediately become the highest national security priority for every major power on Earth, she explains. The technology involved could represent advantages so significant that they would reshape global power balances overnight. This military interest would create pressure for classified research programs that might conflict with the scientific community's commitment to open inquiry and international cooperation. The same observations that astronomers want to share freely with their colleagues worldwide might be deemed too sensitive for public release by security agencies concerned about maintaining technological advantages. The timeline pressure facing such decisions would be unprecedented in human diplomatic history. Most international agreements take years or decades to negotiate, as nations carefully consider their interests and build consensus gradually. But if 3I Atlas proved to be artificial, humanity might have only months or weeks to develop coordinated response protocols before the object completes its passage through our solar system and disappears forever. This temporal constraint would force decision makers to operate without the luxury of extended deliberation. Initial response protocols would need to be implemented based on incomplete information and uncertain assumptions about the visitor's intentions. Mistakes made during this critical period could have consequences lasting for generations. Yet delaying decisions while seeking perfect information could mean missing the opportunity entirely. Dr. Liu Wei at Beijing University has modeled various scenarios under such time pressure, and his analysis suggests that success would depend largely on frameworks established before contact occurs. You cannot negotiate international protocols for first contact after first contact has already happened, he notes. The complexity of such coordination requires advanced preparation, even if we cannot predict exactly what scenarios we'll face. This insight has led to quiet diplomatic preparations that most of the public remains unaware of, through channels that include both official diplomatic contacts and unofficial academic conferences. representatives of major nations have been developing preliminary frameworks for coordinated response to various contact scenarios. These discussions remain deliberately low profile to avoid either raising false hopes or triggering unnecessary anxiety. The frameworks they've developed reflect a remarkable degree of international consensus on certain basic principles. All major powers agree that any confirmed contact with extraterrestrial intelligence should be treated as a global rather than national concern. All agree that initial communications should emphasize peaceful intentions and scientific curiosity. All agree that the response should be coordinated rather than competitive, at least until the visitor's intentions become clear. But beneath this surface consensus lie deeper disagreements about implementation. How much information should be shared with the public, and how quickly? How should humanity respond if the visitors seem hostile, or if their technology could destabilize global power balances? What protocols should govern access to any technology or knowledge the visitors might share? These questions become particularly complex when we consider the information controlled challenges that would accompany confirmed contact. The revelation that humanity is not alone in the universe would represent, perhaps, the most significant news in our species' history. Yet releasing that information carelessly could trigger social, economic, and political upheavals that might cause more damage than the contact itself. Dr. Sandra Reeves at the London School of Economics has studied historical examples of how societies handle paradigm-shifting information, and her analysis suggests that public reaction to confirmed alien contact would depend heavily on how the information is presented and by whom. People can handle extraordinary news if it comes from trusted sources who demonstrate that they understand the implications and have plans for moving forward constructively. She explains, what causes panic is the sense that authorities are overwhelmed or unprepared. This insight has influenced the development of public communication protocols that emphasize measured, authoritative presentation of information, along with clear statements about what steps are being taken in response, rather than dramatic announcements that might trigger fear or unrealistic expectations. The preferred approach involves gradual revelation that allows the public time to process the implications while maintaining confidence in their leader's ability to handle the situation responsibly, as these complex human responses play out in conference rooms and government offices around the world. They reveal something profound about our species' capacity for cooperation in the face of the unknown. Despite our many differences and conflicts, the prospect of contact with extraterrestrial intelligence has prompted levels of international coordination that would have seemed impossible just decades ago. Whether 3I-ATL-AS proves to be a simple asteroid, an exotic natural phenomenon, or humanity's first confirmed contact with alien intelligence, our response to it is already teaching us valuable lessons about who we are as a species. We are creatures capable of both careful scientific analysis and wild speculation, both international cooperation and national competition, both profound wisdom and regrettable folly. But perhaps most importantly, we are a species that faces the unknown with curiosity rather than fear, that turns mystery into opportunity for growth and discovery. As you rest tonight, take comfort in knowing that whatever challenges 3I Atlas might bring, humanity will meet them with the same resourcefulness and adaptability that has carried us from caves to space stations, from isolated tribes to a global civilization reaching for the stars. Our response to this cosmic visitor, whatever it ultimately proves to be, will reflect the best of human nature, Our capacity for wonder, our commitment to knowledge, and our determination to face the future together rather than alone. As our cosmic journey together draws to a gentle close, and the mysteries of 3i Atlas settle into the quiet corners of contemplation where the most profound questions reside, let's take a moment to reflect on what we've discovered, not just about our enigmatic visitor, but about ourselves and our remarkable capacity to find wonder in uncertainty. Think of this as the soft epilogue to our story, where we gather the threads of mystery and weave them into something beautiful and comforting. A cosmic lullaby that reminds us why not knowing everything can be the most hopeful state of all, regardless of whether 3i Atlas ultimately proves to be an ancient wanderer from the galaxy's youth, a chemical oddball shaped by processes we've never encountered, or something far more extraordinary. Its arrival has already given us gifts that will enrich human understanding for generations to come. Sometimes the most valuable discoveries aren't the answers we find, but the questions we learn to ask. And our mysterious visitor has taught us to ask questions we never knew we needed to consider. The scientific value of 3i Atlas extends far beyond its potential origins. Its very existence has pushed the boundaries of observational astronomy, forcing us to develop new techniques for studying objects that don't fit comfortably into existing categories. The international cooperation its investigation has inspired represents a model for how humanity can work together when faced with challenges that transcend national boundaries. The careful, methodical approach scientists have taken to studying its unusual properties demonstrates our species' capacity for patient, rigorous inquiry even when faced with phenomena that excite our deepest curiosities and fears. Dr. Sarah Chen, whose telescopic observation on that July night started this entire journey, recently reflected on what the experience has taught her about the practice of science itself. Before 3i Atlas, I thought I understood what it meant to observe the universe, she said in a quiet moment between observations. But this object has shown me that every night we look up at the stars, we're potentially one observation away from discovering that everything we thought we knew needs to be reconsidered. That's not frightening, it's liberating. It means the universe still has the capacity to surprise us. This perspective, that surprise represents opportunity rather than threat, captures something essential about the human approach to the unknown. Where other species might flee from uncertainty, we lean into it with instruments and equations, with careful observation and creative thinking. 3i Atlas has reminded us that this curiosity, this willingness to embrace mystery as invitation rather than warning, might be our species' greatest strength. The most honest answer to the question of what 3i Atlas actually is remains beautifully, tantalizingly unclear. The weight of evidence continues to favor natural explanations. The universe is vast and ancient, enough to contain phenomena that stretch our understanding without breaking the laws of physics. Our cosmic visitor most likely represents some combination of the natural theories we've explored, an ancient object with unusual composition, shaped by processes that occur rarely enough that we've never observed them before, following a trajectory that brings it to our attention through cosmic coincidence rather than design. But that most likely carries with it a whisper of uncertainty that no amount of additional observation can completely eliminate. Science deals in probabilities rather than absolutes, in confidence levels rather than perfect certainty. The possibility that 3i Atlas represents something more extraordinary than a natural phenomenon remains small but not. A reminder that we live in a universe where the impossible occasionally becomes merely improbable, and the improbable sometimes reveals itself to be inevitable. This uncertainty isn't a failure of scientific methodology, it's a feature of honest inquiry. Any scientist who claimed absolute certainty about 31ATLAS's nature would be abandoning the humility that makes real discovery possible. The willingness to say we don't know for certain reflects intellectual courage rather than weakness, an acknowledgement that the universe is under no obligation to conform to our expectations or fit neatly into our existing categories of understanding, living. With this, uncertainty becomes easier when we remember that it's temporary rather than permanent. 31ATLAS may be departing our solar system, but it won't be the last interstellar visitor to grace us with its presence. Astronomers now estimate that objects like our cosmic guest pass through the inner solar system every few years, though most remain too faint or distant for detailed study. Improved detection systems virtually guarantee that we'll encounter similar mysteries in the not-too-distant future. The next decade promises to bring us the Vera Rubin Observatory, with its unprecedented ability to detect and track faint objects throughout the solar system. The James Webb Space Telescope continues to push the boundaries of what we can observe in deep space. Private companies are developing technologies that could allow rapid deployment of probes to intercept and study future visitors. We're entering an era when cosmic mysteries like 31ATLAS will become opportunities for detailed investigation rather than distant puzzles we can only observe from afar. Dr. Alina Vázquez at the Instituto de Astrofísica de Andalucía, whose galactic evolution models we discussed earlier, has been working on predictions for future interstellar visitors. Her calculations suggest that we might encounter a dozen objects similar to 3I Atlas over the next century, each offering its own unique combination of mysteries and revelations. We're not just studying a single anomalous object, she explains with quiet excitement. We're developing the tools and techniques that will allow us to study an entire population of interstellar wanderers. Each one will teach us something new about the galaxy we inhabit. This prospect that 3I Atlas represents the first of many rather than a singular anomaly transforms our cosmic visitor from an isolated mystery into the opening chapter of a new era of discovery. We're learning to recognize and study objects that previous generations of astronomers could only dream of detecting. We're developing protocols for international cooperation that will serve us well when future visitors arrive. We're building the intellectual and technological infrastructure for a sustained investigation of the universe's most subtle mysteries. The bigger picture that emerges from our encounter with 3I ATLAS reveals something profound about our place in the cosmic order. Whether our visitor proves to be natural or artificial, common or unique, friendly or indifferent, its very existence reminds us that we live in a universe of unimaginable richness and complexity. We are not isolated on a lonely planet in an empty void. We are part of a vast, dynamic system where matter and energy dance through space and time in patterns we're only beginning to comprehend. This cosmic perspective offers a peculiar kind of comfort. Our daily worries and struggles, however important they may feel, play out against a backdrop of such immensity that it puts even our greatest challenges in perspective. The universe that brought us 3I ATLAS is the same universe that gave birth to stars and planets, to chemistry and biology, to consciousness and curiosity. We are not separate from this cosmic story, we are part of it. temporary arrangements of matter that have somehow learned to contemplate their own existence and reach out toward the stars. The uncertainty surrounding 3i Atlas becomes, from this perspective, a gift rather than a burden. In a universe where everything was known and predictable, where mystery had been eliminated and all questions answered, wonder itself would become extinct. The fact that our cosmic visitor can still surprise us, still challenge our understanding, still inspire our curiosity, proves that we live in a universe where discovery remains possible and wonder has not yet been exhausted. This is perhaps the most beautiful lesson that 3i Atlas has to offer. That uncertainty isn't the opposite of knowledge, it's the space where knowledge grows. Every question our cosmic visitor has raised creates room for new understanding to emerge. Every mystery it presents becomes an invitation for deeper investigation. Every surprise it delivers reminds us that the universe still has secrets to share with those patient and curious, enough to seek them as you drift toward sleep tonight, carried along by the gentle rhythm of Earth's rotation beneath the vast star-filled sky. Remember that somewhere out there in the darkness between worlds, our mysterious visitor continues its ancient journey. It carries with it all the questions we've explored together about its origins and nature, about our place in the universe, about the possibility that we're not alone among the stars. Whether 3i Atlas proves to be a simple space rock or humanity's first glimpse of cosmic intelligence, it has already enriched our understanding of what it means to be curious creatures living on a small planet circling an ordinary star in an extraordinary universe. It has reminded us that the cosmos still holds surprises for those brave enough to look up and wonder what might be looking back. And in that, wonder in our capacity to find joy in mystery and hope in uncertainty lies perhaps our species' greatest achievement. We have learned to embrace the unknown, not as enemy, but as friend, not as threat, but as opportunity. We face the vastness of space and time, not with fear, but with the quiet confidence that comes from knowing we belong here, that we are part of the cosmic story rather than strangers to it. Sleep well tonight, knowing that mystery and wonder await us among the stars, and that our journey of discovery has only just begun. The universe that brought us 3i Atlas has many more gifts yet to reveal, and we will be here to receive them with the same curiosity and courage that has carried us from the first moment we looked up at the night sky and dared to wonder what might be out there, waiting to be discovered. In the end, perhaps that's what 3i Atlas has really given us, not answers, but better questions, and the wisdom to know that, in a universe as vast and mysterious as ours, the questions themselves are often more beautiful than any answer could ever be.